Okay, we are starting. Hello, everybody. Thank you very much for joining us on stage 2. I'm so excited to be having there's so many people here. You guys can see it, but there's like, I don't want to say now how many, but we've got tons of people, and more people are continuing to trickle in. I'm very excited to be hosting this stage for you today. It was just a few years ago, I was at it was my first data engineering conference that I attended, and at that point, I was just, I was having this data engineering problem, and I couldn't figure it out, and I was just starting out in the space for weeks. I was struggling with this until I went to that conference. And there I met folks from, in that case, it was latest technologies, it was Spark and Databricks, and folks from Google and Netflix, and so many of the people that are here today speaking with us. And it was through networking with these people and then asking them questions after their talks, it completely changed the trajectory of my career. And I am very excited to be doing this conference and then to allow all of you guys in to come and speak and ask as many questions as you can for these folks. And I have full conviction that this will be as transformative for you guys as that one was for me. I'm your host. My name is Adam Becker from the MLOps community. Let's get started. Our first speaker today is Raj. Let's see. Raj, can you hear us?
Yeah, Adam.
Raj, how's it going, man?
Thank you, Adam. Excited to be part of this discussion and the tech talk. And I always love hearing, as he is a great guy. Yep.
I had the great pleasure of speaking to Raj in the green room, and we were going at it for about 30 minutes, just asking him so many questions about data architecture and the system diagram of how they do everything at Zoom. And I'm stoked for him to share his thinking about how to build a very fast data ingestion with Data Lakehouse. Raj, I'll be back in about 10 minutes. Take it away.
Yep. Yeah. Thank you, Adam. And thank you, audience. So let me share my screen. So there you go. So hi everyone. I'm Raj Singh. I'm working as an engineering manager in Zoom. I'm based out in Bangalore, India. Today I'll be talking about the lakehouse architecture of Zoom, and I'll divide 4 sections this talk. First is the introduction. I'll talk little more about the product of Zoom, and then I'll go deep inside the architecture. Basically, I will drive the bigger picture of our architecture, our data platform, data system architecture, and I will deep dive more on the lakehouse architecture. So yeah, this is the introduction. Like as you all know, this is irony. I'm joining in Google Meet, but as you know, during pandemic, we scaled our user customer to 200 times, and that time was very challenging where we evolved our lakehouse from on-premise to hybrid and now to cloud. Like during pandemic, we started ingesting 100 terabyte of a data per day. We were ingesting 150 million messages every 5 minutes. And before pandemic, we were completely on-premise. We were using Cloudera and Hortonworks data platform. And then when pandemic hit in, our data center was not able to hold all these data. So we started approaching the hybrid approach, and where we started using cloud. And now we are totally on the cloud. So we are using Amazon EMR cluster, Apache Spark, Apache Flink, structured streaming jobs. And we are also using tabular format data like Apache Hudi and Delta. And we build very cost efficient lakehouse architecture in Zoom. So Going back, so for our audience, Zoom is not just a meeting platform. We are the AI first work platform. We provide a lot of products apart from meeting, like we have Zoom Docs, Zoom Webinars, Zoom Contact Center, Zoom Chat, email, calendar, Work Vivo, and lot of products we are offering. Uh, so Zoom is now AI first platform, and not just a meeting. We are offering a lot of products. So please go through this slide, and please reach out to me in a chat. Like if you want to know more about any other products like Zoom Phone, Team Chat, Meeting, uh, any products. So and now coming back to this, the high level architectures, if you'll see, this is the very high level architecture of our data systems. So we have divided our entire data systems into four parts. One is our data source, then we have an ingestion platform. We call it data ingestion platform, and then we have a transformation platform. I will deep down more on this transformation platform because this is the exactly our lakehouse architectures, which is where we are doing magic. And then we have a data serving layer. So our total use case is based on our customers. So mostly product team, DSML team, engineering team are our customers. So we have a multiple data source like third party vendors or Salesforce. We have file story object, uh, and then we have OLTP a MySQL database, and then we have a telemetry data where client events and server logs are there. So we built our own ingestion platform, and we do have our own managed streaming services which are ingesting all the batch job and the real time jobs. And once this job is ingested using our ingested platform in our data lake, then what we did, like our data lake, we created a lake house and we did a data modeling on top of our lake house. So we divided our data lake house into three layers. We call it as a bronze layer, silver layer, and the gold layer. Now, when it comes to bronze layer, so bronze layer we store the Parquet original data, and it contains the full DB and the CDC logs in the bronze layer. And this layer is mostly the append only layer. And the data retention for this bronze layer is very shorter. We can say 15 to 30 days as per the use case, and mostly it supports the real time frequency data. Uh, and uh, it also have the engineering and self serve driven template. Now once we have a raw layer, that is the raw data in a bronze layer, then we built on top of bronze layer, that is called a silver layer. So silver layer is mostly we are storing all our data in a delta format. It has a desired schema table, uh, column naming conventions. It is template driven data we are storing in a silver layer. And it is self-serve enabled layer, and all the role-based role tag and policy-based access control is given in the silver layer. Uh, and also, we are also storing the audit logs, like some of the data we are storing in bronze layer that is getting deleted, and all these audit logs we are also storing in a silver layer. So now comes the more refined layer, that's the gold layer. Most of our customer is using our gold layer. So gold layer is the mostly business ready and transformed data that is being used by our customer. It is also in a delta format, and it's a template driven and self-serve enabled data we are storing in a gold layer. And it supports mostly hourly and daily frequency, but when it comes to raw layer, that is the bronze layer. So bronze layer basically it contains the real-time frequency data. But in a gold layer, we are having a hourly or daily frequency data we are storing in a gold layer. And it also focus mostly on the micro outage, not on the macro outage data. So once means we are storing our data in these three layers. And then we do have a data serving layer. We are using Trino, Databricks, Apache Superset, and also API. And these being using this data serving layer, our customer uses this data. But there are also many corner case in our Zoom data platform. Some of our engineering team or our customers want to access the raw layer because they using API they access a raw layer and then they do the customization on the data and then they built a dashboard, a report on top of that. So yeah, this is the overall architecture. Also, the data retention period. So if you'll see in the bronze layer, the data retention is 15 to 30 days, and then silver layer we are storing a data for 15 months, and in the gold layer the data retention period is longer. So yeah, this is the overall architectures uh, for the Zoom data platform. And yeah, thank you. Please connect me in LinkedIn. And also, if you have any questions, you can ask me if time permits now, or you can please ask in the chat. I will try to answer as much as possible. So yeah.
Raj, thank you very much. I think time permits maybe one question. So let's see. There's been a few in the chat. So if you can remain in the chat after the session is ending, that would be excellent. Let's see if I can pick something out real quick. We have. Okay. How do you manage to reprocess data that's older than 1 month if needed? They're saying that the bronze layer seems to have pretty short retention.
Yeah. So if we need to reprocess the older data, then we have to backfill the data again. So we do have a data in our data source. So if the data doesn't exist in our data lake, then we have to go back to the engineering team and backfill those data into our data lake, and then we customize those data as per the requirement from our customers.
But that's with the assumption that you do have access to that raw data in the first place.
Yeah, yeah, definitely.
But that isn't always. Is that always the case? You can retrieve it again.
Yeah, means we can retrieve always because means our data is always there in our data source. So we do have a data source like DynamoDB, MySQL, file storage, which is being managed by the different team, different engineering team. But in data lake, we store that data only, which is being used very frequently by our customer. But if customer need the older data for the bronze layer, then in that case we have to work with means we are backfill means we have to work with the engineering team and backfill those data to our bronze layers.
Raj, I see that we have many more questions in the chat. So you should go and linger there, and we're going to get started with our next talk. Raj, thank you very much for joining us.
Thank you, Adam. Thank you so much.